All right, we're going to keep going with our work with multiplying powers with the same base, and we're going to look at a challenge problem and then a real-world connection problem. And I encourage you to pause the video, try these on your own, and then check back in and see how you did. So this first one, this challenge problem, we have this sort of crazy long multiplication that we need to do with some different bases. There's a base of 25 in there that we need to think about, but most of the bases are 5. And so the first thing that comes to mind for me is that the 25 is a power of 5, right? So let's see what we can do here. So first off, what I want to do is just do all this work, everything with the base of 5. Let's simplify that down. And so we're going to add all of those exponents together. And so we have 1x, we have 3 minus 2x, and we have 1x. And maybe you can look ahead and see we're going to get some nice simplifying and canceling out. That's going to be kind of cool. And then we still have this 25 to the negative 1. All right, did you see what was going on with these exponents? We have x, x, and minus 2x, which all goes away. So that's kind of fun. And we have, that turns into 5 to the third. And then I'm going to use the negative exponent with the 25 to bring it down over 25. So that turns into 125 over 25. And just doing that division, we get a final answer of 5. So lots of that simplified and went away. All right, next one, this real-world connection problem. So and these are actual values, these are real numbers for sure. So the mass of a hydrogen atom is approximately 1.67 times 10 to the negative 24th grams. And there are an estimated 10 to the 57th grams of 10 to the 57th hydrogen atoms in the sun. What's the mass of the sun's hydrogen? A quick reminder about scientific notation. I'm not going to do a full lesson on this right now, but if we have something like 1.67 times 10 to the negative 24, that means we can take this 1.67 and move it to the left, move the decimal point to the left 24 times. And we'll have a decimal point followed by 23 zeros, which I'm not going to write them all in right now, and then ended with the 167. Okay, so basically we have a tiny number, which makes sense because a hydrogen atom doesn't weigh very much. It doesn't have a very large mass. All right, so let's get rid of that. And I think you can see, if we know that what each hydrogen atom's mass is, and we know how many there are, we can just multiply to get the total mass of the sun's hydrogen. And reminder that we can do this multiplication if we have the same bases. So we are going to, let's regroup, and we can do a 1.67 times 10 to the negative 24th times 10 to the 57. Okay, so we're going to have a 1.67. And then we just need to add negative 24 and 57 together. And we get 33. And that's going to be in grams. Okay, so that would be our final answer. That's the mass of the sun's hydrogen in grams right there. And that's a good place to stop.